another more complicated equation over here. So we have 9 to the power of x plus 1 equals to 1 minus 8 times 3 to the power of x. Oh my gosh, this is so complicated, right? But don't worry, we will kind of see what we can do here. So to solve this equation, number one, we're going to try to make the base the same. So we have 9 to the power of x. Okay, so we can write it as 3 square to the power of x plus 1. Usually in the exam, I wouldn't really write this. I will just jump straight into solving it, into writing the other form. Okay, so from here, I can straight away say that, okay, I'm going to bring everything to the left hand side just for the sake of it, right? So 3 to the power of 2x plus 2, okay, plus 8 times 3x, 3 to the power of x minus 1. Okay, I always like have this problem here. Now, it will be helpful if you could write everything like your equal signs that are kind of like the same. Now you may be wondering why bring over. Because it's not going to be very easy because you have a term here. You have this term here which is 1, and it's not going to be that easy because you don't have 3 to the power x there. So you can't factor out at 3 to the power x from 1. So what we're going to do is introduce something very interesting here. So from here, right, I can actually split this guy. So this is 3 to the power of 2x times 3 to the power of 2, right? Plus 8 to the power of 3x minus 1 equals 0. Okay, and then from here, I can write it as 9 times 3 to the power of 2x plus 8 times 3x, 8 to the power of 3x minus 1 equals 0. Okay, then from here, I'm going to kind of rewrite this, and I hope you see the magic here. I'm going to write it as 3 to the power of x square, because 3 to the power of 2x is simply just 3 to the power of x square. And from here, we add, we just write it out here. Now, if you can see something very unique here, okay, do you see a quadratic equation? Okay, well, if you don't, I'm going to make a substitution here. So now that I have, can you see that this 3 to the power of x is the same thing between both of these terms, right? I am going to let y be equals to 3 to the power of x, just for the sake of it, right? Just for the sake of it. So if 3 to the power of x is equals to y, so I will have 9y square plus 8y minus 1 equals 0. And there you go. I have a quadratic equation. And we know how to solve quadratic equations. We can do many things. If we can factorize them, we can do all sorts of stuff. And so from here, maybe I might just do some factorization. So maybe it could be just this, right? Is it correct? Yeah, I'm correct. Okay, and if I factorize it, I'll have 9y minus 1 times y plus 1 equals to 0. And by 0 product rule, we have 9y minus 1 equals to 0, or y plus 1 equals to 0. Now, from here, we need to solve for, so y is equals to 1 over 9, or y is equals to negative 1. Now, we have not come to the end of the question because we are actually not looking for y. We are looking for x. So let's replace y with 3 to the power x. So we replace y with 3 to the power x. I'm going to write it here. Replace. Okay, maybe my this pointer is too thick. Okay, I'm going to write replace back y with 3 to the power x. Okay, so we replace it and we will have 3 to the power x is equals to 1 over 9, and we have 3 to the power x is equals to negative 1. Now from here, remember we state that for exponential functions, right? Exponential functions cannot be a negative, right? Because for any x value, 3 to the power x will always be positive. So we're going to reject this. Reject this because 3 to the power x must always be more than 0. Right? 3 to the power x has to be more than 0. So we're going to reject this. And what we're going to do is we're going to deal with this. So 3 to the power x is equals, this is simply 3 to the power negative 2. And hence x is equals to negative 2. And that's how we solve a little bit more complicated exponential function where you need to use a little bit of substitution here to kind of see that quadratic equation leaving like kind of just hidden there, and then from there you make some logical conclusions to reject what is necessary. Okay, so that's for work example 4 where we solve more complicated exponential functions. See ya.